In today's lesson, you will learn how to identify a function when you are given a mapping, a graph, and a table. So a function is defined as a relation where every input has exactly one output. So in algebra, inputs are represented by the inputs are represented by x's and the outputs are represented by the variable y. So a relation is any pairing of a set of inputs, that is our x's, to a set of outputs, that is our y's. So let's show how the relations are represented in algebra. So we can represent a relation by tables. So in this case, you see the input x's and the output y, and the input and the output. So each pairing of the input and output are represented in tables. And you can also represent the relation by mapping. So in this case, this first map represents our inputs, and the second mapping represents the outputs in this case. So in the same way, the ordered pairs, so the first value of the ordered pair represents the input, while the second value represents the output y. So for the maps, you see that the arrows also represent how the pairs relate to one another. So in this case, this -3 input takes the output of -6. So a relation can also be represented by a graph. And for that, the graph can either be continuous, in this case, like represented by a line, or it can be discrete, which in this case is so each pair of x and the y's are represented as points on the graph. So we are now supposed to be answering this question. So which of these relations are functions? So the first thing, that when you are given a table and a pair, you have to remember that the value of x's cannot repeat in the table. So let's look at the table. So for this first table, we have -3. The value of the x's are -3, 0, 3, 8, and -8. So that none of the x's repeat. So that is a function. In the second table, if you look at the value of the x's, you see this -2 and then another -2. So this repeats. So this is not a function. So for the first mapping, in the mapping, you have to look at the arrows. Okay, so if there are two arrows going out from the same value of x, that tells you that the mapping is not a function. So for this, all the arrows going out from each value of the x's is just one arrow. So this is a function. But look at this one. This is the x and the y. So look at this -5. -5, I mean, the value of 5 has two arrows going out from it. Okay, so that means this is not a function. Okay, so this is not a function. So this, when you are given a graph, so you need to test the graph with the vertical line. Okay, so if the vertical line touches the graph only one time, that means the graph represents a function. Okay, so now we are going to use the vertical line to test each of these graphs to determine whether they are functions. So now this is my vertical line. Okay, so this line touches this blue graph only one time, so that means this is a function. But look at the second example. So this vertical line touches the blue graph 2 times, so this is not a function. And the same thing with the third example. The line touches it 2 times, so that means this is not a function. And what about this? So look at the discrete point here. So if you look at this negative, when the value of x is 1, you can see that these 2 points, they are both on 1. So that means this is not a function. And this is a continuous line. So if I draw a vertical line, okay, it doesn't matter how many lines I draw, it's just going to touch it once. So that means this is a function. And that's it. Thank you.